Hi, good afternoon, and welcome to we should say how to implement a sustainable steam trap management program. We're going to give it another minute before we get started, and if you could just hang on, we'll let a few more people come in. In the meantime, please hum a tune to yourself of any likable theme song that you may choose. I don't hear anything, Rachel, so they're not humming as much as I thought they would. About 30 more seconds. Rachel, you give me a cue when you want me to start, okay?
Sounds good. All right, I think we can go ahead and kick it off, Ray.
Awesome. Well, good morning, good afternoon, or good evening, depending on when you're picking up this session or if you're listening to a recording. Just a quick housekeeping tidbit before we begin is that today's session will be recorded. So if you do not want to be recorded, please drop off. And we'll be sending the recording out afterwards. Please stay on mute throughout the entire session as we are recording. And if you have any questions, please post it in the Q&A chat that should appear to the right side of your screen. We'll conclude today's session answering some questions. And don't worry if we don't get to your question right away or in the time of this session, we'll do our best to get back to you directly. So with that in mind, let us get started on implement a sustainable steam trap management program. Today, I've got a few people joining me, even though I am the only one on camera, as luck would have it, some technical challenges befell us, but you can take a look at our esteemed panel right there. I'm gonna go right to left. We have Maddie Hawkins, who is our resident IoT expert. She'll be joining the panel discussion for questions. My name's Ray Michek, longtime Maximo person since 1997, an IBMer, and one of the partners at Aquitas. We also have our resident manufacturing and CPG expert, subject matter expert, Nicholas Despain, who is also a CRL. A certified reliability leader. And the focal point of today's session is a good friend of mine that I've known for years, same as Nicholas. I think I've known both of them for nearly 20 years now, is Bill Studler, the maintenance engineer from Penn State University. He is also considered the guru of steam. Bill, is that correct?
That might be a little bit of a stretch, but I have a strong interest in steam. For many years, even before I came to Penn State, realized the value of steam and the cost or the savings that an organization could achieve.
Yeah, hence the guru of steam. That's what I'm going to call you. And hopefully the next time people see you at one of the events, whether it's Maximo World or the Mug event or anywhere, they will come up and say, I know you, Bill. You are the guru of steam. And you're also an expert on Maximo. You guys have been using Maximo at Penn State for as long as I can remember, and probably one of the major university customers, one of the first major users of Maximo in the university segment. So I'm just excited to have you on board. Okay, with that in mind, once you advance this slide there for us, Bill. Let me go through the agenda, what we're going to cover. We've done our introductions. We're going to talk about why manage steam. And this is a topic that Bill and I've discussed over the years, and the same with Nicholas and Maddie. We get together and talk about steam, and it's amazing how much there is behind the scenes and why and the importance of why you should manage steam traps. And Bill's going to get into that. He's going to talk about the Penn State program and an implementation strategy, and then show you guys how Maximo supports that process. And then the next steps of that will be what's in store and what's the changes in steam. Again, we tend to think of steam as this innocuous energy that's flowing through our facilities and manufacturing organizations, and there's innovations that are actually taking place. And then we'll go through some Q&A and hopefully get into some healthy discussion on steam. Okay, Bill, I'm sorry, I'm going to laugh every time I talk about it, just because it's a steamy conversation that we're going to have. Go to the next slide, if you will.
Okay.
Oh, and I do want to say to you, just a quick introduction about Aquitas Solutions. We were founded in 2006. We have over 250 customers. You see some of our customers there. In fact, today, right now, I'm at one of our customers, Encore Boston Harbor. I'm coming to you live from my hotel room where we're having a customer meeting, and I broke away to have this discussion. But we've been around Maximo for quite a long time. We're a gold level IBM business partner, won multiple awards, and have a customer base that's very diverse. Bill, and what do they all have in common at each of those customers? That's right, they use steam. Maybe not to the extent that Penn State does, but they are also consumers of steam. So next slide.
Okay,
all
this
right,
is my
Bill,
slide. First of all,
this is you. Go ahead, take it over.
Yep. First of all, let me start off by thanking everybody for attending this webinar. The intent is to provide some motivation to maybe investigate this at your organizations, because there is value to be had by managing your steam trap population and your steam systems. So starting, I'm not going into a whole bunch of detail about Penn State. We're a land-grant university in central Pennsylvania. We have many units across the state, but just focusing on University Park, we're equivalent to a small city of 65,000 people daily. So that's our population that's coming and going. That doesn't count game days or anything like that.
Oh, Bill, Bill, hold on. Now, while we're on the topic of game days, Penn State's doing really well in football right now. How many people typically attend or at a home game? How many people do you have in the stadium?
The most recent whiteout we had 110,300 and something or something like that. We were in the stadium.
That's amazing. So if you got 65,000 typically in your small city, you had almost a 75% increase in population on game day.
And that doesn't include everybody that's in the area either.
Right.
So if you see the stadium kind of up there in the upper right corner, you see the stadium. You see all that grass lot with little lines on it, like it looks like it might be cultivated or something like that. Those are filled with cars and RVs and things like that, all the way, to the right and even beyond the border that's showing. And then going to your left, where it shows a little oval up in the upper left, or almost center of the screen with the yellow line, that's all filled up with parking up that way too. So there's quite a few vehicles, here in that little vicinity. So if there are maybe 4 people per vehicle, that's 25,000 vehicles, give or take a few hundred. So so it's quite the operation on a game day. And it's quite the operation every other day of the week also. A couple of facts around the campus in regards to steam. We generated 1.23 billion pounds of steam last fiscal year. That'd be a July 1 to June 30th is our fiscal year, or a calendar year, whatever, in a year's period. And our cost of steam is $23.45 per 1,000 pounds. That's a pretty standard way of identifying how much your steam costs. And that takes into account fuel, labor to produce the steam, capital equipment, and depreciation. To renew your process for generating steam and things like that, maintaining the distribution system and all that. So based on that gives us a steam value of $28.8 million per year. is what we have flowing across campus, providing space heating, hot water to the to the buildings to keep the comfort level where it needs to be. So,
Bill, can you repeat that figure again?
Yeah, there's 1.23 billion pounds of steam. The cost of our steam is $23.45 per 1,000 pounds, and the steam value is $28.8 million per year.
That's pretty surprising, right? When you think about it. So interesting.
Yeah.
Thanks.
Yep. So then, so continuing on, we have a couple of thought-provoking questions for the group here. Do you know how much steam you're producing over some period of time? Day, a week, a year. So you can calculate. So there was a poll question set up for this, but something went wrong with that. So we're not going to worry about that at this point.
Before
this is
you
more
move
for your
off
own self-reflection.
Yeah, before you move off of it, in discussions that we've had with customers, and Bill, I think you've been involved in some of those discussions. My guess is that people really don't know that. If we did that poll question and you answered it, you may be the only one. Well, you and Nicholas may be the only two people that I know that know that. Now, again, there could be some other, I don't want to say steam nerds out there, but it is one of those things that just kind of flies under the radar in most organizations. So let's make an assumptive close there, Bill, that most people don't know the steam production rate over a period of time. They may know generally, maybe a year, but not into the detail that you have it. All right.
Yep.
Move along.
So,
yeah.
A fairly easy way to do that would be to go look at the nameplate on your boiler, and you could go to that manufacturer's website, and it will tell you what that machine is capable of producing per hour, basically. So there's ways of finding that out. It's not as monumental as you may be thinking at this point. It's not like we need to have a steam meter out there that's measuring the flow of steam, but you could actually, knowing your boiler infrastructure, what does each boiler produce, and what's the operating context in a year? Is it 50 weeks a year, 7 days a week, type of thing? So you can actually back into that number fairly easily and get that value. And it doesn't have to be that big of a boiler to get to a fairly large number. A small boiler, say a 3,500 pound per hour boiler, will produce 29.4 million pounds a year of steam. That's based on 24 hours a day, 7 days a week, 50 weeks a year. So it's not that difficult to predict what you're going to need. The next question is, in fact, this one is hard. This one here will be really overwhelming. Do you know what the cost of your steam is? I talked about earlier about the cost of fuel, and labor to produce it, makeup water, chemicals for your boiler treatment, all those types of things get factored into that cost of steam, plus the capital and of the equipment itself, time value of money.
So let's have people answer that. The poll appears. Select one of the following. Of course, there's only two. Do you know the cost of steam? Either yes or no, if you could do that. And Rachel, who is helping us host this webinar behind the scenes, will let us know when we have some results, and will reveal that to us.
All right. Yeah, I'll give it about 10 more seconds.
Log your answers in.
Okay, we'll go ahead and close. So it looks like 32% said yes, 68% said no.
Okay. What do you think about that? I think that's actually pretty high, right? 32%.
That is probably more than I was anticipating. Yes, definitely. That's good that you kind of know that. And if you're lucky enough to know what your production rate is, we're going to talk briefly about what your potential savings could be and we'll dive more deeply into this in a minute. So in a program that we implemented, we did an intermediate program. We're checking our traps twice a year, and based on some EPA findings and facts published by them, and and it's kind of the litmus test that we use to say this is why it's good to do this program. So if you're checking your traps, say once a year, you could cut your potential steam loss in half. If you check them twice a year, you can also cut that number in half again. Or basically, another published fact from the EPA is they're saying an unmaintained steam system will have a 20% loss from leaking traps.
And Bill, it's a fact that it's an interesting fact that my other good friend, Nicholas Despain, taught me, that a steam trap's going to fail. It's just a known fact that there's a certain percentage, as high as 25% of your steam traps are going to fail at some point between inspection. And it seems like you're validating that based on your experience.
Yeah. So to wrap up the thought, then 20% steam loss from a system, and if you check your traps once a year, you're 10%. And if you check them twice a year, your loss is 5% instead of that 20%. So using 1 million pounds of steam a year, just to use a good round number, 20% is 200,000. And if I check my traps twice a year, I'm only losing 50,000 at that point.
Let's dig into some of that. What do we have on the next slide here? So
this is what we talked about, and Nicholas has said this too. Eventually, all steam traps fail. 25% of your population per year is not unheard of, depending on applications, indoor, outdoors, the quality of your steam, things like that. But why do you want to do that? Why do you want to manage your traps? One of the first and probably foremost in everybody's mind is reducing energy losses by eliminating the steam that's blowing out the trap that's pictured over there on our right. So that's the technique that we use to validate and justify why we want to do steam traps and support the ongoing process. Why do we keep investing in this every year? The other, and I would contend the more important aspect, is increased system safety and reliability. Worse than a trap that's leaking is a trap that is not discharging the condensate from the system. If it's not discharging the condensate, you have a buildup of water. That water could start moving down your steam line at a high velocity and cause a rupture or a failure at some joint, a valve, an elbow. And then the subsequent response would be the loss of live steam and hot condensate into an uncontrolled space where people may be present. Reliability side of that.
Hold on. Bill, is that what you call the water hammer, or am I getting that confused?
That'd be water hammer. Yes, exactly.
So the danger, I always picture it like, for some reason, the Terminator movies, where they always go into the old factory and they shoot, and then they hit that steam and it burst out. But what you're saying is that could happen because of the buildup of the condensate. Am I saying that right? And then it could explode somewhere where at a weak point along the system.
Yeah. So as the condensate starts building up in your pipe, you start getting some wave action and things like that. And if it gets to a high enough level where it completely encloses the inside of the pipe, that slug of water will now be traveling down the line at the speed of the steam, which is typically 100 feet per minute in that range somewhere, I believe. And And water is heavy. I mean, a gallon of water is 8 pounds, well, a little bit over 8 pounds. So I wouldn't want somebody dropping a gallon of milk on my chest from 5 feet, let alone 100 feet per minute.
Yeah, no kidding. So I like the way that you positioned it, and again, the whole idea of this webinar was to get people thinking about the steam trap management in a different way, and that really the safety aspect and the reliability aspect is the true benefit. You know, one accident could cause an issue, especially if you don't have a program in place to say that you are actively checking them. But the reduced energy loss is what pays for that safety. So basically, what you're doing is providing a program that pays for itself to be safe. I like that.
Yes. Yep. Yeah, exactly. And then obviously there's the decreased greenhouse gas emissions because we're not burning as much fuel. That's pretty straightforward. And then the improved steam quality. You have dry saturated steam, which is the most efficient heat transfer media you can put into your process vessels or your heat exchangers to make hot water. And you're not just putting, your biggest energy gain is when steam condenses from a gas to a liquid. That's your biggest energy, gain.
Well, let's get into what you do about this.
Okay. We kind of
this.
touched on this a little bit already. We talked about this back in the poll questions. These are just some of the facts that I talked about. I'll just kind of repeat them real quick and we'll get moving on since we got other important content to get to. Like I said, this is from EPA fact sheets and on, surveying many organizations and many companies across the United States. Like I said, 20% of the steam leaving a boiler plant is lost via leaking steam traps. Steam systems that have not been maintained for 3 to 5 years, 15 to 30% of the installed steam traps may have failed. And this is what I talked about, the simple program versus the intermediate. Checking your traps once a year is a simple program, and that cuts it in half. Using an intermediate program, which is 2 times a year, basically, reduces it in half again, or, your 5% of that 20% loss. And it's this pretty simple device. It's pictured up there, excuse me, in the upper right corner. That's just a handheld ultrasonic probe that contacts you put it on the trap connection, and it can filter out background noise and things like that. So you can kind of hear the flow of condensate through the trap, or the rushing of steam if it's failed open, for example, or the rattling of something inside if it's broken loose, for example. If the float or the bucket in a steam trap has, completely come loose, it'd be rattling inside. So you can pick that up in the middle of a manufacturing plant, noisy environment. So what is the program? It starts based with the steam trap survey. Where are my traps? What are my traps? Things like that. It's data management. So I know where my traps are at. I know if they're failed or not. Engineering analysis. Do I have the right traps installed? Is it the right size, the right type for the application? And then it's repairs and replacement. And obviously, it's back to the steam trap survey, which at that point now it just becomes a routine work order. We go out, we survey or test each trap again and report how it's doing, and it just becomes a self-sustaining cycle that we're going to talk about how we use Maximo shortly to support that. This is just a graphic, excuse me, that kind of shows the steam trap management process from the work order perspective. The top 4 boxes are the routine PM. We generate a work order, say every 17 weeks. Our technicians that are trained in using the ultrasound devices go out, check each trap in the system for that particular work order, record the condition of that trap. Did it pass or did it fail? And complete the work order. So that inspection work order is now done. The next step we use is we leverage condition monitoring in Maximo to look for the traps that we reported that have failed blocked or failed leaking and all those types of failure modes. And that uses condition monitoring with the cron task enabled to create a Maximo follow-up work order for the failure. And then our technicians perform the follow-up work to repair or replace the trap. And they complete that work order, and that kind of completes that life cycle of we inspected, say, a building, and we found this handful that failed, and we repaired them.
So the process actually is fairly simple and straightforward. Let's talk about that next slide, which will tell us a little bit about the assessment, where to start, because that's really the big thing is getting started, right?
Yep. Yeah, that's exactly it. It may seem like kind of overwhelming, but if you're methodical and take it one bite at a time, it's not overwhelming. I guess that's the best way to say that. So the program basically consists of, you do it like we said, like we had in that circular diagram. It's a survey of the installed trap population, gathering important information. We're going to go into detail about what that is briefly, but it's kind of what's the trap, what type of trap, what's it trapping, for example. Then PM-based routes to check the steam traps regularly on whatever frequency it works for your organization or company.
Bill, I just want to make sure that we didn't lose you. It might be me, but I still have you on slide 11.
I'm on slide 12, didn't it?
Rachel, there we go. Now we're at slide 12. Thank you.
Okay. I went back and came forward. Okay. Thank you, Gray, for pointing that out. Yep. So anyways, for those, if it may not transmit anywhere except for my screen, there's a survey of the installed trap population, which is, what type of trap, what it's trapping, those types of things. Then in a building or a location of the facility or something, you set these up into routes to check the steam traps regularly. We decided to use characteristic meters for ours when Maximo 7.5 had that availability. We went to that method, so it's more common sense for the people reporting what's happening. Did the trap pass? That's obvious. Is it failed leaking, or is it failed blowing through? Is it failed blocked, for example, or different things that we report. So it's more intuitive to the people that do the inspections to be able to report. And again, we talked about the automatic follow-up work order for the failed steam traps. So the whole program is basically looking at answering a couple of questions. Is the trap installed and working correctly? And if not, has it been misapplied? Is it the wrong style of trap for this application? Or has it failed in open or closed position? Going back to the open, we fixed that. We're saving energy and greenhouse gases. If it's closed, we're improving reliability and safety because we're not removing condensate. We want to make sure we remove that. So here's some of the essential data. So if you started doing a survey or you started doing your facility, this is the essential data, and it's all can be captured on, Maximo supports this very well. The location, the manufacturer, the model, size and connection, the steam trap maximum pressure rating. That's valuable to know when you want to start grouping your traps to see if you want to do some other more exotic monitoring, maybe continuous in the future. So you want to look at where you have your high pressure traps and things like that because of the potential for more loss. Steam trap type, that could be a thermostatic, a thermodynamic, a floating thermostat, a bucket trap, for example. The system operating pressure. Again, that goes back to what, grouping the traps for some other method of continuous monitoring, for example. Equipment being trapped. That would be a process trap. It could be on a chemical reactor or a heat exchanger or something like that. Or it could be a drip trap that's on a steam main. So it gives you that quality information of, when I have competing interests, what one should I do first? Our philosophy at Penn State is that if I have a trap that's blocked or failed and not eliminating the condensate, we do that first because of the safety implementations over the savings of energy. That's just we're risk adverse. The other part is the replacement trap and or repair parts. A lot of traps are just one item. It's a fairly small item. Total cost of a new trap is not that great typically. And so for us, it's more of just a replacement. So this trap's failed, we take that one out, put the new one in, and move on. Larger process traps would have repairable parts to it, maybe a new orifice or a new seat that seals the valve and controls the flow out, things like that. So there's just, it's not a lot of information, and it's not that hard to know, and it's pretty easy to set up a survey form. Somebody can go out and collect the data into a spreadsheet type, form, or properly setting up your asset record. You could actually do it live in the Maximo, obviously.
Yeah, it's just a matter of configuration to adding those elements in there. And again, if you keep an eye on the payoff, the setup takes a little bit of effort, not a whole lot, just some time and dedication, and then you can load that information in. How about we talk a little bit about some tips that you can give on setting up the PM program? Because I think you guys do an awesome job at that.
Okay. Yeah, and the last button there is, standardize the inspection routine to start with the first trap in the system. So there's this little funny graphic that kind of shows, trap 1, trap 2, trap 3 as you're progressing away from the boiler. Obviously this is a very simplistic system. You could have T's that go, in the system that go to the left and to the right. It's just kind of an organizational mindset is, okay, we start with the boiler, we get to the first T, we're going to go to the right, and we're going down that line till we get to the next right and keep going. Then you come back and you go left, and you come back and go left, and it's what it just gives our people an idea of how they're going to progress through the system. Because in our facilities we have some rather large buildings. Steam is not just in one room or anything like that. It can go up through a chase up into a mechanical space on the roof and things like that. So for us, the layout may be a little bit more complex than some organizations, or maybe not as complex as some other organizations, like a refinery or something like that.
So are you saying, Bill, are you saying to start with the trap that's closest to the source?
Yep, exactly. Yep.
Okay.
Yeah,
right.
It's just there. Oh, that's what we've done. It works for us. There might be some other ways of doing that, but that just seems to be a logical way to do it, and that came from some published information from steam trap manufacturers such as Armstrong or Spirec Sarco and the like. And just some, the PM-based inspection program. We enable it with Maximo because we have Maximo. We create the inspection routes of closely located steam traps within a building, or if it's a small building, we'll have multiple buildings on a route to get a nice population of traps to be inspected per work order. The limit of traps assigned to a route to 100 items. That is comes more from the ultrasonic testing realm, and that group of people who provide the equipment to do the testing. The 100 items is magical because that is what a surveyor could comfortably do in an 8-hour shift if traps are close, relatively close together. If you're traveling back and forth across your campus or your refinery or your paper mill, for example, that doesn't count. This is basically, if you got 100 traps that I can go to, and survey with a little bit of walking, that's a comfortable number that you can do. That's all I'm saying with that. Don't make a route of 500 traps because the technician could get lost where he started and ended on the paperwork or on the mobile device in that case. So the steam trap testing procedure is fairly straightforward. I think this is getting into the weeds slightly, but I think it's good to understand what the full scope of this effort involves. So basically, your first question is the steam system operating? If it's not operating because it's the summertime and we're not using it, there's no reason to check it. So the first thing is, if the steam system is operating, you check the steam trap temperature. And the question there, is it hot? And if it's cold, that's an indicator that it's failed blocked. It's not, discharging any condensate. Or if it's warm and not hot, like the steam temperature, that's an indication it may be undersized, basically. And if it's hot, it comes down to now you select your steam trap test procedure based on the trap operation. And that is the type of operation of the trap, on-off versus a continuous flow. On-off traps are inverted bucket traps, thermostatic traps, thermodynamic traps. I'll leave it to the attendees to kind of go out and do a little bit of searching on trap manufacturers to see what these different type of traps look like. Usually they have a pretty unique appearance to them, so if you know what you're looking for, you'll see them in your facilities. The continuous flow style is a floating thermostat, and the fixed orifice, which is basically just an open orifice in your steam line that restricts flow, and it's sized to a specific application of a certain pounds per hour and things like that. They're nice because there's no moving parts, but they're not. The turn down or rangeability of those is not as great. So you test the steam traps per the instructions and record the results. Did it pass or did it fail blowing through? And this is all part of the art of this, is that testing procedure, what to listen for, what it sounds like, and that comes with training your technicians and supporting the effort, basically.
It outlines the process really well. So we've got about 15 to 20 minutes left, Bill. So I think the next thing is to show what kind of how you've done that in Maximo. We can breeze through a few of those slides if you'd like.
Yep. Now that's what we'll look at, the setup, what we set up, and we'll kind of go through these quickly. And for those in attendance or those who listen to this after the fact, there will be a contact information for a person at Aquitas to reach out to, and we can answer more questions or do a deeper dive into these different features. So one of the first things we do is set up the condition monitoring point, and you'll notice that it's a characteristic meter, trap condition, basically. And then when you set up that point, you set up your characteristic action values, which is fail, block, blowing, cycling, flooded, leaking. And there's different repair job plans over there to the right. And we just use trap replace 6, 1, 3, and 4. That's just what our job plans were called. We elected to go with job plans in lieu of PMs. PM would be a fine way of doing that, except that's a lot of PM records you set up to manage that program. So our steam trap population at Penn State's in the 9,000 range. So instead of having 9,000 distinct PMs that call out the particular asset and things like that, we elected to go the job plan route. And then when it does fail, we use an escalation to add some attribution to the work order. We'll talk about that here briefly. So we set these up in routes. You see at the top where it has the steam trap count there. Knowing the level of effort, because we have a lot of buildings, and they vary in how many traps they do and how much time it would take to do each one of those routes. that root stop count is important to us. We actually embed that into the PM record, and then we evaluate that at generation to know what line of the job plan. We use a trap inspection job plan that in turn has the, if you notice the middle of the screen, there's many lines there. We have a craft 323, and you see over to the right has like 30 minutes, an hour, hour and a half, 2 hours. That's a function of the conditional label we put on there. Or down below, you see at the bottom left corner, it says steam trap route stops 16 to 23. So we have a conditional expression that's being evaluated that's looking at the PM description for that 18. Basically says, does 18 exist in that? What's that value? And is it between, in this case, 16 to 23? We have all those different conditions set up, and each one of these labor lines has a different condition level to it. So that's how it gets evaluated. I don't know who's looked at conditional expressions on job plans. It's powerful. It has a lot of features that are nice, and this makes it semi-automatic for us as long as we get the right count on the PM record, which isn't too difficult to do. And then it just gets evaluated. Again, this is stuff we could dive in.
Yeah, you're doing a great job here in terms of not only doing the work, because it would be one thing is to just go out and do the inspection, but this allows you to really hone down your return on investment because you're capturing the cost to do this, which is really great.
Yep. So then, in the end, the work order is generated from that PM record. It resolved to one line of labor because that's the line that matched the criteria of being 18 on that PM record. And this is just a few quick screens. This is what our technician sees. He's doing the probe we saw earlier, testing the trap, and he selects from the drop-down list pass, or what's its failure. Gets recorded on device, saved back into Maximo, and then a work order is generated.
One note on that, Bill, before you move on. So you're using EasyMax Mobile to do that inspection, correct? So I know, and IBM has come out with some really good inspection apps as well. So just to let the audience know, there's multiple ways to do that, but the EasyMax Mobile really serves you guys well.
Yes, it does. Yep. Yeah, I think you could use inspections also. I think there's feasibility in doing that, the new inspection stuff that's being provided by IBM. And even doing it within the applications of Maximo itself. Quick reporting or even the work order tracking application could be done there. But yeah, this is just what we're doing. There's other ways to do that too, obviously. So anyways, like I said earlier, we have a cron task that's running against the condition monitoring tables, looking for failed traps or failed assets, and generating the equipment or generating the work order automatically. And some of the things that happen on here, so we know the asset we're generating it from, so it gets populated on the work order. The trap job plan we're going to use is down below. We have two different job plans depending on the size of the trap. So if it's an inch or less trap, it takes a little bit less labor to do that. If it's a larger trap, it takes a little bit more time because of just the size of wrenches you're using and the size of materials you got to work with. And then the other thing we're doing, this is what I talked about earlier, is we populate other critical fields with the escalation. So basically, we're looking at an escalation is running, looking for anything that begins with the job plan trap REPL, and then it sees that and it knows what to do with that record, adds the CM work type changes the status to waiting plan, populates the failure class and the problem code based on what the trap reported failure was. So we actually add a lot of content to the work order and saves anybody having to go look at it to affirm what's going on. We're relying on what our technicians are sending back to us. And then the only step really our planners have to do at that point is identify the replacement part we need. And you go to the Plans tab. You click on Select Asset Spare Part, because when we set our records up, we ensure we put the replacement trap item on the asset record. Or if it's a larger trap, we have the repair parts we need right there. So you click on that button, it brings up this little dialog box. You select the parts you need and click OK, and now it's returned to the work order. And at this point, we can forward this, this work order gets moved forward to our scheduling group to get assigned to our work group and the resource assigned to it and execute it. All in a pretty
it's
pace.
great. Yeah, you got it really self-contained there. We got about 5 minutes left. I don't mean to rush you, but there's a couple of these last slides that I think are really important. This oversight and some of the costing things and KPIs. So
then the oversight part of this is the report metrics, things like that. Number of steam traps replaced, steam saved, the monetary savings associated, leaking traps waiting for waiting for maintenance. Blocked or flooded traps. Again, going to that safety component, we want to know how many we're seeing that are blocked or flooded, and how many are waiting for maintenance. That's important to us. And the total cost of the program, the cost of the surveys and repair, including parts and labor. And it's just using KPI Manager, or using KPIs in Maximo. We just have a series of KPIs that are running. Gathering up this information and providing it to us. And the two I'll draw your attention to would be the monetary savings, which is the third one down. We're basing that on traps that are leaking, and we're making an assumption that we wouldn't find this trap for 120 days once it started leaking. So it's going to go 120 days before we repair it. So how much steam did we lose, and what's the cost we're calculating based on that? So
that's really cool. Hey, Bill, I'm dark again. I don't know if it's me or you. So you might have to go for, there you go. That to me, that's really cool, because you're seeing what the savings are and what you're realizing, so you can share that with management. It's really cool.
So then you see at the bottom metric we have there is the program expenses, the last 365 days. So we can go out and we can gather up our total cost. What did the inspections cost us to do? What did the repairs cost? And you can compare that to what you're saving.
Yeah, I like that too. So you told me that you have about 1,000 traps, is that right?
About 9,000.
9,000. All right. So your percentage is a little bit better, but you've been working on replacing them. But you had 91 traps fail last year, for the 12-month period, right?
Yep. Yeah, this is, keep in mind with COVID, our inspections may have been down, things like that. So a little, not our normal year, obviously. But that's one of the things to keep in mind. And one of the, I would refer to as kind of maybe short-sightedness about the program is if you're not doing anything with your system right now and you do a survey, you find all kinds of traps that are leaking, blocked, failed, to replace those, you're going to see a definite jump in your savings of steam and the cost of fuel and things like that, because you've replaced so many traps. Once you have the program established and it's kind of ongoing and sustaining itself, you don't get the large numbers like that.
Yeah, that's right. It baselines a little bit. Then it's just the normal failure rate. That first year's where the big savings. In fact, go to that next slide, because I think that's really interesting too. Yeah.
So just to summarize, and then we're going to talk about what our next steps are going to be, or what we're considering. Again, Maximo has the tool set that lets us manage this with little effort, little ongoing effort, a little bit of effort to set it up, but it's not overwhelming. With high rewards, just by doing planned inspections and prompt replacements. And so we talk about a small system, like a 3,500 pound system per hour, relatively small boiler. It has a projected savings of $26,000 for a 90-day period, starting, say, December 1st to the end of February. This is the program we're talking about, or kind of indexing this to, is the cost of steam. The cost of steam is at $23.45 per thousand, using an intermediate program. And if we didn't do anything, we'd be losing 20% of our steam. So that's $26,000 savings. And like I said, this is using everything that's out of the box functionality that's in Maximo. A little bit of configuration stuff, but it's pretty much assets, just PMs, routes, condition monitoring, conditional job plans, conditional expressions, and an escalation. So it's not monumental. It's just good applications of how Maximo works.
Right. So if you go to that next slide, then we've got a couple questions that we got to get to, is this next steps. And
okay. Yep. Yeah. So this is what we're looking at. So we're looking at next steps in our current program. Say a smaller trap, and it's blowing through. It's costing us $14.39 per day. Excuse me. A little bit bigger trap has a pretty good jump in the cost per day. So the question to be answered there is, does continuous monitoring have value? And depending on the application, it maybe has value. At $14.39 per day, and there's the one line, the example that's there. I missed it when I glanced at the screen here. It talks about, we expect every 17 weeks, say it failed at the mid-interval, or 59 days till the next inspection. The best case steam loss is $849, for that 59 days. Is that sufficient savings to cover the cost of an ongoing program? So one thing to keep in mind is a trap is not going to fail every year. So that trap is going to be continuously monitored for a number of years and fail at some point. It's when that failure happens is when you start accruing expenses. And is that expense greater than the investment you made to that point, basically? But when you start talking larger traps, it's definitely a value to do that. Using the other use case we had, there was $75 per day loss cost. 59 days is $4,467 when you start calculating out the 59 days.
Yeah, and Bill, there's some thoughts about next steps and whether you automate that through something like an IoT solution where you eliminate kind of the cost of doing the physical PM, so you have some labor savings to add into it, and then you just catch them when they fail.
Yep.
That's great. You've done a great job of laying it out. I know that there was most people don't think about steam the way you do, and you've really thought through the process and applied it to Maximo, which is awesome. We've got a few questions that came in. I know one was directed to Nicholas Despain in regards to, how does this relate? We're not a facility. How does this relate to a manufacturing environment? Nicholas, I thought that might be a great question if you've got a quick answer there. And then I think there's a couple other ones before we wrap up the call.
Yes. As far as manufacturing, this actually applies to everybody. Anybody that uses steam anywhere. The typical lifespan of an average steam trap is about 4 years. Now, granted, you may have better ones in there, but most contractors I've ever known, they always go with a low-cost provider, which means you're not getting the top-of-the-line steam traps, which means you can expect failures. But I just one note on this whole program. This is a very comprehensive program, and there's lots of value in it. But this is also, like you mentioned, a great opportunity for those looking for an IoT solution, especially on those larger steam traps. You can get a lot for your money going with an IoT option in this as you've set up this whole comprehensive program. You can see the potential savings, but it can even be higher as you automate some of that inspection process.
But I'm muted. This applies to everyone, and even though Bill's got a great process, which sets the foundation for how you attack it, he's got all the information that he can go about and go through automating that and choosing the ones that he wants to automate. So that's good. All right, Rachel, do we have time for one or two more questions that came in?
Yeah, let's do a couple more. This one is more directed for Bill. Did you keep the same PM program during COVID? Did anything change?
Yes, we did keep the same program going through COVID. As a university, even though we may not have had on-campus in-person classes, Penn State is actually a very large research institution. So we had researchers here throughout the pandemic, continuing their research. We have a large animal population that needs to be taken care of. So it was pretty much business as usual for our steam trap program and general operation of the campus.
Awesome. Another one here. How big of an impact does your steam trap management have on meeting Penn State's sustainability goal, like GHG reduction?
It's a definite impact. It is a positive impact to the reduction. It comes down to we're just not burning as much fuel if we're not leaking steam to the atmosphere. You're saving energy because you're returning your hot condensate to your boiler, so you're not heating up, tap water from say 50 degrees, 55 degrees to the boiling point at pressure of whatever you're operating at. So you're saving that energy, and you're just not, and you're getting the useful utility out of your steam when it condenses to, condensate or back to water. You get that large energy gain in your process. So it's just the efficient use of the steam.
Bill, that brings up an interesting point in terms of funding for programs like this. Whether you do it yourself, you do it internally, or you automate some of these things with an IoT solution, that you actually can reach out to other groups. The sustainability budget may have funding as a way to help implement this program. Again, whether that's through configuration assistance or through automating or applying an IoT solution to this. So I think that's just interesting that you're using Maximo in a way that branches out a little bit further than just maintenance and reliability, and it goes to other parts of the organization. All right, so that's all the time that we have. Bill, thank you so much. It was a very steamy conversation. I always enjoy listening more. We're going to have some follow-up on this on our next series. We're going to talk about the automation of this, which Bill had mentioned he's looked at. Nicholas probably will join us for that as well. So there's some really interesting solutions that are available to Maximo customers and non-Maximo customers that can help apply some of the things that Bill talked about. I did want to thank the MORE community. That's the Maximo Online Resources and Education group that helped promote this. It's a great kind of community to get your information about Maximo, and lots of events always taking place. So thank you for joining us. If you have any particular questions or we didn't get to your question, please email Rachel at her email address below, or give her a call and we'll get to you as soon as possible. We'll package this up and get this out to everybody as soon as we can. Thanks for joining today. You guys have a great rest of your week. Take care.
Thank you.